Hi, good morning. So my name's Adi. I'm the founder of Applied Blockchain. We're a company that's been around almost 3 years now. We're based at level 39 in Canary Wharf, and we've been developing blockchain smart contract applications during this time. I'm going to explain to you, as a techie, my perspective on what blockchain is all about, and then take you through some of the work we've done as well, so hopefully to give it some flesh and show you some real projects. Okay, so the first thing to think about in terms of the technology itself is that this is a technology that enables disintermediation. Now, I'm talking about technical disintermediation. What do we mean by this? Imagine today you have two different companies that want to exchange some important information with each other. This may or may not be financial, but it's something that's important and critical to the business. Now, if they do it today, each party has its own IT infrastructure, has its own systems, may or may not be cloud hosted, but it's within its control. Now, you want to send that information to your counterpart, you typically send it to them directly. If you do that, they've got their systems where they're hosting their information and their view of the world. Now, if it's really important information and you do this over time, there is a chance that things might go wrong. So for whatever reason, you've sent them information or they've sent you information and you become out of sync. If this is important information, especially if it has sort of financial implications, then you're going to want to make this process more secure, more reliable. And the way to do that today is to introduce somebody in the middle. Right? So instead of you each having your view of the world and not being able to agree on what the data or transactions look like, you introduce a trusted intermediary. And they hold a system of record that you both trust. Okay? And there are many, many situations in the real world, in the financial world today, where we have intermediaries whose sole purpose sometimes is as this trusted record between parties. So the first thing you can do with blockchain technology and a blockchain database is you can actually have the parties transact directly with each other and be assured that they're looking at the same records, the same information, and they haven't been tampered with, without the need for a trusted intermediary acting for that purpose. So how does this work? How is it achieved? So at the end of the day, the blockchain is just a different type of database. Okay? It's a database with special properties. It's a distributed database. So instead of having a database in the middle, hosted by one party or hosted in the cloud and controlled by one party, we distribute the database to a number of different parties, typically to the counterparts that are transacting with each other. And no one of them has necessarily more control over this database than the other. So if you look over here on the left, you've got this network of 3 different parties who are all exchanging transactions with each other. They each have an identical copy of all of the transactions that have ever happened in this network. Okay, so that's the first kind of basic principle of blockchain, if you like, is that everything is everywhere. We all have identical copies. What this gives us is the ability to remove the need for central control, because if I've got all of the transactions myself, I'm less dependent on others. Okay, I've always got my copy. So we've also got redundancy. If anybody else disappears from this network, I'm less worried because I've got a copy of everything myself. The second property we've got here is it's immutable. And it's all relative. But what we mean by that is that the way that the transactions that have happened in this database are recorded over time is using something that we call blocks and hashes. So what we do is we take the transactions, we package them up into blocks, and we create something called a hash, which is like a fingerprint of that set of transactions, of that block of transactions. And then the next block of transactions that's produced has embedded in it a fingerprint of the previous set. And so we get this chain where each new set of transactions has a fingerprint of the previous set. Now what that means is that if we agree about the fingerprint at the top, so the latest set, which points to the previous one, which points to the previous one, which points to the previous one, etc., that implies that we agree about the entire contents of all of the transactions and all of the data that happened up to that point. Okay? Because if anyone was to change any of that historical data, so if anyone was to tamper with any of those historical transactions, that would change the fingerprint of that block and therefore the fingerprint at the top. Okay? If anyone's got any questions about that, it's a little bit technical, happy to answer later. But the bottom line is that by agreeing about something very simple, which is a fingerprint at the top, we're agreeing about everything that's ever happened since then. And if anybody tried to defraud the ledger or enter any change into the ledger itself, that would essentially be overridden by the rest of the parties in the network, because they wouldn't agree about the hash or the fingerprint at the top. Okay, this is what it gives. This is what gives it this immutable property. Then the third point is visibility. So, in order to ensure that each of the parties can independently have a copy of all the transactions and the data, and be able to check their validity, and know that they're still immutable and they haven't been tampered with, we need to be able to see the transactions. So people talk about blockchain and encryption together, but actually the main blockchains, the public ones especially, Bitcoin and Ethereum, are not actually encrypted. All of the data on Bitcoin and Ethereum is completely visible to everybody, unless it's been encrypted before sending into the blockchain. So for example, with Bitcoin, anybody can go in and see the balance of any account. Anybody who has a copy of the ledger can inspect it and see all of the transactions, the balances, and so on. What you don't know, of course, with a network like Bitcoin is who's behind those accounts. And not knowing who's behind them is because all you have is an identity number. You don't have any identifying information against that party. So that's what gives it this pseudo-anonymous property. Okay, so it's anonymous in the sense that we don't know who's behind the accounts, but once we look at an account, we can see everything about it. And finally, blockchains in general are open source, and this is because you've got a number of parties who don't trust each other. They're connecting and sharing data and transactions through a network. The way the security and the trust is being implemented is through the code of the blockchain software itself, which each party is holding. And so to trust each other, they need to trust that code. And to trust the code, it needs to be open. And that's why blockchains in general are open source, because the code is the rules of the game, and we all need to be able to see, be able to see the rules of the game in order to trust them. I should just a slight disclaimer on this. This is blockchain 101, so these are like the basic principles. Since Bitcoin first came to the world about 9 or 10 years ago, we've had a whole flurry of different versions of blockchain that have been developed. And this list is going on and on. There are lots of people trying to make the blockchains more efficient. And so different variants may or may not still be implementing these core principles. I'll talk a little bit later about some of those. Okay, so now that we've got the basic principles in place, how does it actually work? So here we have two parties, each hosting a node. And a node is basically a copy of this blockchain ledger. So each node has a copy of the blockchain software and the blockchain database. And as said earlier, the blockchain database is a copy of all of the transactions, all of the data that's ever happened on the network. So as an example, if I take my laptop, connect it, I'm online, and install Bitcoin software, my Bitcoin software on my machine will initially, over the internet, find other instances of the Bitcoin software and download the entire Bitcoin database from those other machines. Okay, so before my machine starts working, it loads every single transaction since day one of Bitcoin. And so we've got these ledgers that have all got an identical copy of the entire ledger. Now, in the world of blockchain, we have accounts, also known as wallets, and we have transactions. So the accounts and wallets are basically how you identify yourself on the blockchain. Okay? In the world of Bitcoin and Ethereum, the public blockchains, an account is basically where you hold your cryptocurrency balance. Now, an account has two parts to it, okay? And it's based on private public key cryptography. So your account has two parts. It has a public key and a private key. Typically, you create these keys on your device. The private key will never leave your device unless you choose yourself to remove it. Your public key is like your public account number, so it goes onto the blockchain and anybody can see it. So we've got these two sets, the private and public key. So if we've got two different ledgers here, Each ledger has a copy of all the accounts, so of all the public keys that are used in this blockchain network. Okay? Now, I've got an account on there, account A, and let's say my account has a balance of some cryptocurrency tokens. So this is Bitcoin, and I've got a few Bitcoins against my account. Their value is going up nicely, so I'm very happy. Now, a transaction is basically, I want to transfer some of those Bitcoins from my account to someone else's account. So they're moving from account A to account B. So that transaction is basically a movement of tokens from one account to another. And you can see that here. Those transactions happen over and over. Multiple transactions are basically sent into the network, and they're grouped together over a fixed period of time. So in the case of the Bitcoin network, it's around 8 or 9 minutes. And each of the nodes, so each of the copies of Bitcoin, will be collecting and listening for all the new transactions that have been shared and sent into the network and shared. Okay? Now, each one now has a copy of the last set of transactions that have happened in the last 8 or 9 minutes. The difficulty with this distributed database, distributed architecture, is how do we agree about those transactions? So it might be that a blockchain node in Hong Kong has received a slightly different set to a blockchain node in London because of timing, because of network issues, and so on. So what we do is we have a consensus mechanism. And that's basically a way that all of the nodes can come to agree about the latest set of transactions. In the case of Bitcoin, this is what we call mining. So there's a challenge, a mathematical problem, which each of the pieces of blockchain software, each of the nodes is trying to solve. The first one solves it correctly and is declared by the network as a winner. And they get to present the set of transactions that they are aware of for the last 8 or 9 minutes, and the rest of the network accepts it. This is the basic consensus mechanism. Once that's agreed, the block is sealed, and the next block is opened. When the block is sealed, everybody's got a copy of it. We're all agreed about the transactions that have happened to date, and then we move on to the next block. So that's how it works in principle. We've had 3 generations of how blockchain is used. The first one is these tokens. So against my account, I've got a token, and a transaction is moving a token from one account to another. Then people looked at this and said, this is very interesting. But actually, we don't just want to use it for cryptocurrencies. We could use this type of technology to record ownership of any type of asset. And so we've got this second generation of blockchains where, against my account, I've got recording of ownership of any type of asset. And it may be a land ownership, or it may be a gold or any other type of asset that can be, where ownership can be digitally recorded and recorded against my account. And then a transaction just becomes moving that asset, which is recorded against my account, moving on to someone else's. Now, the reason why blockchains are really useful for this is because of the trust. If we all have a copy of this ledger and we trust that it isn't being tampered with, then we use it as a reliable source of record of ownership. Okay, it's very difficult to undermine. It's very difficult for any one organization to corrupt it, or any individual working at any one organization. So I like to think of what I've described to date in terms of the technology as a kind of see you in court method. Because what we've got here is we've got things that have been recorded in this ledger, and they're being recorded as evidence and as asset ownership. And if anybody has any query or any dispute, they can go to this ledger, which again is very difficult to tamper with and to corrupt, and say, here is the evidence that I own this asset, or here's the evidence that this transaction occurred, or that this data was sent into the blockchain. So it's good for historically going back and checking and validating and proving and providing evidence for ownership or for data and transactions. Now, what I like to think of as the third generation of blockchain technology is what we call smart contracts. Now, the idea of smart contracts was looking back at what I've just showed you. So having this secure, trusted ledger for managing tokens, for managing assets, again, very interesting. But in the real world, transactions are a bit more complex. They typically involve multiple steps. They typically involve multiple parties. And wouldn't it be great if we could capture the workflow and the process around those transactions using this type of technology, so in a decentralized, trustless environment? The idea was that this could make a lot of processes that we have today a lot more efficient. So how does it work? In general, a smart contract is a piece of code, and it looks a bit like the code we've got here. This is an example of a smart contract on the Ethereum network, and Ethereum is the platform which really brought smart contracts as we know them today to life. The idea is that we can, in this code, first of all, we can store data. So just like with any piece of code, we can define a set of data items. And that means that in the blockchain, we no longer have to store just tokens or even a representation of an asset. We can actually store any data we like. Okay? The second thing we can do is permissions. So we can determine, through the code, we can define rules of who's allowed to touch this data, who's allowed to change it. So to give you an example, we could be looking at the conveyancing process. So let's say I'm in the process of buying a house. I put the property on sale. I define a smart contract, which has the property details in there as the data, and it has me as the owner. I then invite bids from potential buyers. And so buyers, anybody who identifies themselves as a buyer, I'll give them permission to put their bid into the smart contract. That buyer might then want to bring their lender along, right, to prove that they've actually got the financing in order to purchase the property. The buyer can permission their lender to actually write to this contract, so that nobody else is actually allowed to fulfill that role except for that lender. So within the contract itself, we can build in those rules. Then because it's code, we can also create a workflow, so we can force sequence. We can say, first of all, the seller puts the property on the market. Only then can the buyers come along and bid. Only once they're bidding can they prove that they have the financing. And finally, only once the financing is in place, can the sale actually go through. So we can force this sequence because we can shape the code. And finally, we can use the smart contract to drive movement of tokens or assets. So if, it's a big if, this blockchain is recognized as a land registry or as a registry of ownership of property, and, again, a big if, this blockchain has a token whose value is recognized as an exchangeable value by the parties, then this contract can actually switch tokens one way and ownership of the asset the other way. So payment and delivery in one transaction. Now, having all of that together in an environment which isn't controlled by any of the parties and so can't be corrupted by any of the parties, but is trusted by all of the parties, and with the ability to do all of this execution and enforce all of these rules, this is really a new paradigm that we have. And this is why we have all of the excitement, really, looking in this space at all the different business environments, business processes, consumer applications, and so on, where the way we transact and the way we do business could be modified and improved and enhanced and made more efficient using this type of paradigm. Okay, so generally, we think of the smart contract and the way they enforce permissions as safer than what I showed before, because the smart contract can stop things going into the blockchain which are not valid, because in the code, we can put in those checks. So rather than this kind of see you in court method where we're going in afterwards and checking for evidence, here we're stopping things from going in the first place because we can build a business process around that. Now, there are a number of platforms out there at the moment. There's actually over 100. And if you follow the ICOs, the numbers are just growing and growing. Lots of people marketing how they've solved all the problems of the previous platforms. The core, I'd say, the sort of most widely used platforms that are out there at the moment are, in terms of the smart contracts, Ethereum, which is the platform that launched the smart contracts in the first place. Ethereum has a very large developer community, but like most of the public blockchains, has major issues around scalability. Hyperledger is IBM's implementation of originally something very similar to Ethereum, but has now evolved into something much more enterprise focused. It's developed by IBM within an open source community under the Linux Foundation and is used generally by enterprises. And Corda, over here on the right, is developed by, sorry, your left, is developed by R3, which is the banking consortium, with a large number of banks involved in that one. Despite all the headlines, the way blockchain is actually used in the real world today is really very limited. Most of what you see is actually being done in lab environments. And there's a huge, huge difference between setting up some code and running it and seeing that it works in a lab environment versus actually transacting and using it in the real world. So we have the public blockchains in the real world, and we have one or two enterprise applications starting to move in that direction. But in the enterprise world, it's still very, very slow and very, very gradual. Of course, in the public blockchains, the ICOs, the startups, and so on, things move much quicker. And so we do have a number of applications that are starting to be out in the wild, generally on the public blockchain implementations, but still very, very narrow number of applications. Okay, so a little bit about ourselves. We're a software development company, Applied Blockchain, founded almost 3 years ago. We're close to 20 people now, based in Level 39 in the FinTech Accelerator in Canary Wharf. We've been fortunate enough to work on over 20 projects over this time. And our client base is split 50-50 between startups and corporates. We've developed our own framework, a blockchain smart contract development framework, which is basically the accumulation of reusable assets that we've gained and we've learned from all the projects that we've worked on. So all the things that we've had to do over and over again in order to save time and costs in developing these projects and make the whole process more efficient is packaged up in a framework that we use. We've got full stack capability in the team and really some really experienced developers. In terms of customers, again, we've been very lucky. We've got a range of startups that we work with and partner with. So an example is Signatize over there, which is a signatory management list. So companies have these lists of who's allowed to sign on what, but the way this is managed and the way this is communicated to their counterparts is archaic. So here we have an application which uses a tamper-proof ledger to share and demonstrate to your counterparts who is allowed to sign off on things. And actually, not managing that list correctly has in the past led to fraud and corruption, where people leave a company, the counterparts think they're still allowed to sign on things, and actually they're not. So a very useful application that's already live, that's Signatize. Appy is a bit like LinkedIn on the blockchain, so verified education and work credentials. And again, you can go into the Apple App Store or the Android App Store, download and use that one today. The idea is that employers can look at somebody's CV and they can see what's been verified and what hasn't. So your university signing the fact that you've got your credentials, you've done your degree with them, and you've got the grades that you claimed. Your employer approving that you've actually worked there for that period and that was your role and so on. So really making the recruitment market more efficient. Nuggets is around managing data privacy for consumers. Satoshi, who are here as well, and TallySticks. Satoshi is around commodity repo financing. TallySticks around financing for SMEs. And then we've got the corporates we've been working with. So initially we did some work for some of the banks. BAB, some of you may have seen, which is a banking application for the developing world, giving access to people who don't have identity documents, but yet opening up access to financial services to them. We did some work with CETA, a very interesting project for a commercial drone registry, which CETA is now marketing to the civil aviation authorities of different countries. And this is where commercial drone flights are recorded on the blockchain, and approval of those flights by the authorities is recorded too. And the drones, as they go out and fly, their flight paths are reported by the drones. And if they veer from the approved flight path, then evidence of this is recorded on an immutable, trusted ledger. and so on. So this is a way of enforcing commercial drone flight activity. We did another project with SITA, with British Airways and Heathrow Airport, around synchronizing flight information. Not on here, but we've done some work in the telco space with Vodafone and Telecom Italia as well. And most recently, we've started working in the energy space with Shell. We're working on trading, and we're working on supply chain as well. In fact, I'm allowed to talk about this. It was announced last week in the press. We've just received our first investment from Shell and from a London-based VC called Calibrate. So we're really excited about that. It gives us growth capital going forward as well. So the framework that I mentioned to you earlier, this is kind of the lessons we've learned in developing all of these blockchain applications, and it's summarized in this framework that we've developed ourselves. It covers architectures for distributed applications, improvements for system performance, identity management, which is required in every single blockchain application out there, manages data privacy, which again isn't a given in blockchain, and actually has to be controlled and managed very carefully. And we've done this in a blockchain platform agnostic way. So we don't know which platform is going to emerge as the dominant platform in the future. And this is a very new technology. There are lots of people experimenting. And as we're building these applications, we're building them in such a way that they're protected from the underlying blockchain implementation. So if today they're developed on Ethereum, tomorrow they go onto a new version of Ethereum or they go onto a different platform, we architect them in a way that that should be a relatively painless process. We've got a great team, a growing team, again, based in Level 39 in Canary Wharf, but really experienced developers. And this is just an screenshot, if you like, from some of the applications we developed. So this is Signitize that I mentioned earlier, for managing the signatory lists in a company. BAB, again, an application for banking, developed using blockchain infrastructure to massively reduce costs of running the platform and therefore cost to consumers. Nuggets, which is around managing consumer data and privacy in a decentralized way. So again, not having to share your data with one large organization as we do today. Another partner we're working with is a company called Increment. And this is around the token issuance space where we've now developed a platform, and Increment is the first token issuance which is running on that platform. Increment itself is a company that looked at ICOs and token issuance and realized that actually it's very open to fraud. And so what they're doing and what we've developed for them is a series of smart contracts which lock up the funds that are raised in an ICO. And the idea is that there's a set of tranches and a set of milestones which are broadcast by the product, by the companies that are doing the token issuance. And the funds only get released to those companies, to those projects, when the token holders vote that the company's actually reached the milestone. Okay, so the smart contract is actually holding the funds in escrow. So that's Increment. And we're also starting to develop our own community around the projects that we're building and that we're involved in, and the technology that we're building for those projects. And so we've got a project called Pablo, which we're developing and which will have its own, will also be powered by a token, and more details of that to follow. And we're growing. We're almost doubling the size of the company this quarter. So there's various information out there, the roles we're looking for, but in terms of developers, JavaScript developers, front-end, React, Node, we're looking for a product manager, we're looking for solution architects. Anybody who's interested to jump into this space, start working next week, next month on some of the most exciting projects in the space, please reach out to us afterwards. That's it.